Okay, here's a continuation of the basic lessons on functions. And so I had, in the previous video, two sets, A, B, C. I had the set B, which was 1, 2, 3, 4. And I had the function G, which mapped A to B. And I defined function G by specifying how it acts on every single element of the domain, which includes the elements A, B, and C. And here's how I defined the function G. G operating maps the, and so we can say here that G maps A to 1 is how I can read this statement here. And you can see that I've defined G on all three elements. Another shorthand for specifying this is to put the elements of the domain in the column and to label, oops, it's supposed to be function G here, to label another column with the corresponding elements. Okay, so G maps A to 1, it maps B to 1, and it maps C. Oops, it maps B to 2, doesn't it? And it also maps C to 2. And so you can see that this is an alternate way of specifying a set. Another way of specifying a function G. Another way of specifying is graphically. I can make my sets like this. Here's the set A. I'm going to draw sort of an oval, and I'm going to put the elements of A inside of A. Then I'm going to make another set B, and I'm going to label dots inside of it that are the elements of set B. And what I'm going to do is I'm going to say that the function maps the domain to the range. And I'll do that in this case by mapping little a to 1, mapping little b to 2, and mapping c to 2 also. Okay? I can do that. I can define it however I want. And so this is the function. That's not the function f, John. It's the function g. Okay? This is the function g then. And I've defined it three different ways here. I can specify. So here's three different ways to specify or define a function. Okay. First way is to list out all the elements. Second way is tabular, and the third way is graphical. Okay. So for example, if I use the graphical technique, suppose I wanted to define another function, A, B, C, from A to B, 1, 2, 3, 4. Suppose I wanted to map A to 2, and I wanted to map B to 3, and C, okay, so C to 4, let's say. If I also drew an arrow that mapped A to 1, then I'd have a problem. This is not a function. Because f of A is not unique. F of A appears to be both 1 and 2, so we're not allowed to do that, okay? So f of A, or g of A, I meant, boy, I'm going to just keep calling it f. G of A is not unique because I have the arrows from A going to two different elements. Here's another case where I'm defining it graphically and where I don't have a function. Let me label it up real quick here. Suppose I map A to 1 and B to 2 and leave it at that. then I've got a problem here. This is not a function because it's G, John. G of C is not defined. And we have to define our function's behavior on all of the elements in the domain. So this is the set A, the set B, the set A, and the set B, and here's me trying to define a function G here this way, and then another function G here that way. Okay, so this is a basic introduction to functions and mappings from the domain to the range. 3 different ways of specifying a function, and we'll leave it at that for this video. Thanks for watching.